record. Is वह सब join करेंगे? वह सब? Oh, admit all. So let's start this again. We are doing bar charts, representation of data, bar charts. If I surveyed over 150 people, 20 people like cold drinks, 16 people like coffee, 34 people like tea. So that 34, 40, 40 and 10, 50, 60, 70, 70, and maybe I interviewed 40 people like, so I interviewed 110 people. So this means that there are cold drinks are the most popular drinks because of the population. But these people are independent of the tea drinkers and the coffee drinkers and the juice drinkers. So what we understand is that bar charts have spaces between them. They are independent. They are independent of one another. They are independent of one another. Each character or statistics we are gathering has nothing to do with the other one. There is another word you use is there is no continuity. Okay, so there is no continuity in a bar chart.
I can't see your video.
30 seconds. I'm sorry.
I wasn't able to see you.
Can you see the space now?
Yes, sir.
Okay, I give you 30 seconds. I give you 30 seconds to copy this. Please copy it.
Sir, I can't see your screen.
You can't see it?
Sir, we can.
Can you see it now? Can you see it now?
No, sir.
Yes, sir, we can see it.
Sir, we can see it.
They are pretty clear, man. I don't know what you could see. So the first part of today's lecture, part A, is talking about bar charts. Bar charts are independent of one another. I can talk about bar charts as people. I can talk about what they prefer to eat at home. How many people like to go to Chinese restaurants? How many want to go to Pakistani kokas? How many want to go and have barbecue? How many like fish food, fish or seafood? So we can have different kind of options, but they're independent of one another. They're not interlinked. Okay. Done. So we'll go on to part B now. Part B is about histograms. Now there's a fine line between the bar charts and the histograms. The histograms are also like the bar charts. Only problem is they are neighbors. Okay. So again, on the y-axis we go frequency, and the x-axis we have anything that could be age. It could be age. Let's take for data about people on the age. I gathered data of people 0, 10, 20, 30, 40, 50, 60, 70, 80. So I start from here. I go into the data I see a continuity in age. In this case, the x-axis is age. Please try to understand this really carefully. It's not a tough thing to do. You just need to understand that this is age and there's a continuity. I went to Park Towers and I was interviewing people and their ages. Ladies, let's take for instance ladies. So I thought 0 to 10, I got say 20 people. 10 to 20, the age group, the teenagers, they were around 30. 20 to 30, age group, there were 40. 30 to 40 aunties doing household groceries, 50. And this could be 45. And this could be another 30. And this could be another 25. And this could be 7, whatever. So what I found out was that we have a continuous data. And remember one thing, histograms may or may not be of the same spacing, So histograms need not necessarily have the same spacing between them. They can be, one barrier could be bigger than the other barrier, and then we don't write frequency over there. That's a different thing. As you go in class 11th, 10th and 11th, I will teach you frequency density. But this is one way of representing data. This is definitely one way of representing data. Okay, so you have histograms right now. There is a continuity here. The age is growing. There is a continuity here. Okay, so I'm giving you like 35 seconds to copy this. This is part B of the lecture. Done. Part C of the lecture is another kind of a histogram, but its spacing is different. Here you have different spacing. So you call it a histogram, but in reality, you draw a frequency. You don't write down y-axis as frequency. No, you don't. It's untrue. People who say this is frequency are not being truthful. This is called frequency density. Because, and again, this could be age or any other thing, we have a program. This is part C of the lecture. Today is the 21st of September 20. The problem that is arising here is that now the histograms have different spacing. This is 10, this is 20, this is 25, this is 30, this is 70, 60. And this is 70. So the spacing here is 10, another 10. This is a 5, a 30, and a 10. So what we understand now is that there is a possibility that histograms have different spacing. There are some calculations here which I shall teach you as you go ahead. Okay? So we understand that their calculations will come later as the level 3 of this topic. But right now, copy this, please, copy this. This is called a histogram, but it's called a frequency density graph. Frequency density in the y-axis and age. I'll teach you as you go ahead. Done. So I will take this now. We started with bar charts, then we went to histograms, and then we went to okay. Now, one interesting thing. Everybody who's sitting here in my class right now will be making a table because we are doing representation of data. This table will have number of alphabets. Number of alphabets, tally marking, and frequency. Okay? So my students, all my students, we have number of alphabets in words. Let's talk about a sentence. Ali has been a very good student of mine since the last 3 years. Okay? Now this is the sentence. Ali has been a very good student of mine since the last 3 years. This is the sentence I've written. And we are going to make tally marking. Number of alphabets 1. Number of alphabets 2, 3, 4, 5, 6, 7, and so on. Now let's look for one alphabet words. One alphabet. A, just one. You do a tally mark here. and the frequency is 1. This is gone. Two
Sir,
alphabets.
So there are
can't
two.
you for isn't
Okay.
it
Well, what happened? I'm sorry, I can't hear you. You have to be a little loud, Johnny. I can't hear you.
sir, isn't a present three times, once in Ali and then has and then a?
Ali has been a very good student of mine since the last 3 years. So, is a one alphabet word. Okay, so we just do a tally mark here of 1.
Okay, sir.
Then we go into 2. Do we have a two alphabet word? No, we don't. We leave it. Frequency is 0. 3, 1, 2, 3. Ali, okay, is a 3-letter word. Has is a 3-letter word. The is a 3-letter word. And that's it. So, sorry, this is for here. You'll be marking it here, not here. 1, 2, 3. 3. Not bad. Let's go to 4-letter words. Bin. Bin is a 4-letter word. 1. Okay. Very is a 4-letter word. Good is a 4-letter word.
Mine
Mine
and last.
is a 4-letter word. Last is a 4-letter word. Chuck. This is called tally marking. Tally marks. And you write the frequency as 5. Then you go 5-letter words. 1, 2, 3, 4, 5, 6, 7. 7-letter word. 1, 2, 3, 4, 5. Since.
The 3
1,
and
2,
years.
3. 1 years. Y-E-A-R-S. 3-letter words. So we have 1, 2, 3, and the frequency is 3. Do we have a 6-letter word? No, we leave it. Do we have a 7-letter word? Yes. Student. 1, 2, 3, 4, 5, 6, 7. That's 1.
So we also have a 2-letter word.
They're off.
Yes. Off.
Where's the 2-letter word?
The student.
Off.
Off.
Have a off.
Off.
2, 1, 2-letter word. Now, remember one thing. Please look at me. I'm teaching you something really nice. Let's take, for instance, Moby. Moby, that's me. Didn't see that. Okay? Imagine Mubeen missing the off words. Now, how can you be sure that you've not made a mistake? You count the words. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you have 14 words in the sentence. And let's count the frequency. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oops. So the total should match with this. So then you check again. Oh, you missed out a 2-letter word. Okay. Now we got 14. Total is 14. Good enough. Good enough. Good enough. So this is called tally marking. Tally marking is also a way of representing data. This is part D of today's lecture. Today is the 21st of September, 2020. Copy this, please. You have a minute to copy this. This is called tally marking. I obviously have this lecture on record now. I'm recording this lecture, so you people will probably get it. If you need it again, you can copy it. You can get it over there in case you miss something out. You can ask Mr. Reyes to get it. I'll save this lecture for you guys. Okay. So we've jumped from the easy ones. We're jumping on to part E of the lecture. Okay? This is called tally marks. I would expect students to actually write this sentence down and do it and see how I'm cutting it. That's the good way of learning how to do it. cut it off. Okay? You take another minute, copy this properly. And Ubaid Qureshi Saab is going to put it to you on the YouTube. So you can just go on the YouTube and see the lecture for yourself. Okay? Good.
What is the channel name?
You can coordinate with Mr. Qureshi. He'll tell you what the channel is. Okay. So I'm going to get this out now from here and go on to E part of the lecture. The E part of the lecture is as good as it gets. And you guys have done this all your life. And these are called pie charts. Pie charts. Pie charts are a circular way of representing data. The advanced pie charts, which are not part of the syllabus, are also available. They have things in degrees. This is 90 degrees. These are represented by cars on the roads, on Main Khayaban Ittihad. And this is 80 degrees. And this is 70 degrees. So the 90 degrees. And this is Mr. X, rickshaws. The bikes, motorcycles. And these are trucks, or let's call them buses, preferably buses, okay? Buses. And this is X. So all my students know that around the point that sum of the total angles are equal to 360 degrees. Sum of total angles are 360 degrees. So what we do is we do X plus 90 plus 80 plus 70 should be equal to 360. 90 and 80 is 170. 170 and 70 is 240. X plus 240 is equal to 360. Therefore, X is equal to 120 degrees. Congratulations. This baby turns out to be 120 degrees. Now, as you go ahead, I'm writing something very important down. The total survey of today, I did a survey and the total number of cars, total number of vehicles we surveyed was 7,200 vehicles. 7,200 vehicles. So now I need to write something down. If we are to solve any pie chart, we must know the relationship between the angles. We must know the relationship between angles and people, or degrees and vehicles. So if you know the relationship between degrees This is called degrees and vehicles. Then you can solve the question. So I'm marking 3 stars on this, and I'm giving you, today is the 21st of September 2020. I'm allowing you exactly 1.5 minutes to copy everything on this board, because now I'm going to do some questions with it, okay? If we are to solve any pie chart question, we must know the relationship between angles and people, degrees and vehicles. Please copy this so I can go ahead and do it on a new board. While this board will remain here, I will do a solving on another board. So copy this right now, please. Let us do 2 questions, 2 subparts of this question, so that you people can understand the approach to this question clearly. Okay?